Okay, welcome to the video on simplifying, evaluating, and factoring expressions. Now, expressions are problems that have variables without an equal sign. So, for example, x plus 2 is an expression because it does not have an equal sign. So it's just representing a situation without actually solving it. Okay, so looking at the first question, we have distributive property, which is something you need to understand to be able to evaluate expressions. So the first thing we're going to do is rewrite this problem using distributive property, and then we're going to solve it. So distributive property is multiplying this outside number with the number on the inside of the parentheses. So that would be 3 times 8, which is 24, and then 4 times 2, which is 8. And then we're going to bring down the plus sign. So that's rewriting. That's this first part. And then the second part is actually evaluating, which is also known as solving. So we're going to do 24 plus 8, which is 32. So solving it would be 32. Rewriting it would be 24 plus 8. So depending on what your teacher expects, maybe both answers are just one. But because it said rewrite and evaluate, I would expect you to write both of these answers. All right, looking at the second one, we're going to do distributive property with two monomials. A monomial is either a number by itself, which is also known as a constant, a variable by itself, or it could be a number times or multiplied by a variable. So like 2x is also a monomial, or 2xy is also a monomial. All right, so doing that, we're going to multiply this 4 by everything on the inside. So think of it like a teacher. This teacher is number 4, is going to be passing out paper or distributing papers to everybody in the class. And in the class would be the inside of the parentheses. So we're going to distribute a paper to the x, and then we're going to distribute a paper to the 3. So 4 times x is 4x, and 4 times 3 is 12. And because this is a positive 4 times a positive 3 gives us a positive 12. So because we cannot go any further, because we cannot combine a monomial that has a variable with a monomial that does not have that same variable, this is as far as we can go. So rewriting it is the same answer as evaluating it. So for this answer, number 2 is just 4x plus 12. Unless they gave us a value for x, which in this problem they did not. All right, and the next one we have negative 2 times y, which is negative 2y, and negative 2 times negative 4. A negative times a negative gives us a positive. And negative 2 times negative 4 is a positive 8. And again, like I said up here, we cannot combine these two together because 8 does not have a y. So that is as far as you can go. All right, moving on to the next slide. We have evaluate the expressions if x equals negative 3 and y equals 4. So evaluating an expression means that you're plugging in values for what they give you. So they gave you that x equals negative 3. So instead of writing x, this time we're going to write negative 3. And 18 stays the same. And instead of writing y, we're going to write 4. So now you're just going to evaluate or solve the problem. So negative 3 plus 18 gives us 15. Minus 4, 15 minus 4 is 11, and that's the answer. Now with this next one, we have y to the third power. Well, I know that y is going to be 4. Let's rewrite this. And our x is negative 3. So instead of writing y, I'm going to write 4 to the third power and copy down the 14. And 4 to the third power is 4 times 4 times 4, which is 64. And then bring down 14. And 64 plus 14 is 78. So the answer for number 2 is 78. All right, now looking at number 3, let's give us some more room. Instead of writing 4x, I'm going to write 4 times negative 3, which is what they gave us in the key and above. And then instead of writing y squared, I'm going to write 4 squared and put it all over 2. Now remember order of operations. So we have parentheses, exponents, multiplication, division, and addition, subtraction. So I'm going to do the parentheses first. So I have negative 12, 4 times negative 3. And then I'm going to do my exponents next. So 4 squared is 16, so negative 16. And that's going to be all over 2. Now, the next step would be your multiplication and division. However, it's a lot easier in this situation because we have a fraction to do what would be at the top. So pretend like this has parentheses on the top, and we're going to do what's in there first. So negative 12 minus 16 would give us negative 28. And then dividing it all by 2, well, negative divided by a positive would give us a negative answer. 28 divided by 2 is 14. So the answer would be negative 14. And now we're going to move on to the next problem. Simplify expressions. Simplify is just a fancy word for combining like terms. So we're going to combine the things that are alike and try to simplify it as much as possible. So I like to do box and circle. So I'm going to circle anything that has just a number, and I'm going to box anything that has a variable. And I make sure when I box and circle to include the sign in the front, the positive or the negative. And because I have 2 boxes in this question, I'm going to be able to combine them. So we have plus 3 and plus 9. So positive 3 plus 9 would give us 12, and they're both A's. And then we can't combine anything with the 2, so we're going to drop it down. And because it's a positive 12, we're going to make it positive, and that's as far as you can go. We combined all like terms. The 2 cannot combine with the 12A because there's no A next to it. So that's as far as you can go. So moving on to the next one, we are going to box and circle again. So we're boxing anything with a variable, circling anything with a number, making sure we include the positive or negative, boxing anything with a variable, circling anything with a number. Now in this situation, it's every other one. So what I like to do is I like to pretend like this one doesn't exist when I'm doing the 2 boxes. So I'm going to rewrite that as 12C plus 4C. And 12 plus 4 is 16. So it's 16C. And then I'm going to pretend like this 4C doesn't exist and rewrite it as negative 3 plus 7. And negative 3 plus 7 is going to give us the positive 4. So because this has a C on it, in order to combine it with the 4, this would have to have a C. And because there's no C, that's as far as you can go. That's in simplest terms. So it would be 16C plus 4. Wow, I can't speak right now. 16C plus 4 is the farthest that you can go. So that would be your answer. Butterfly. All right, for number 3, we have 4 times x minus 2. So we're going to do distributive property first. So 4 times x, which is going to give you 4x. And 4 times negative 2, which gives you negative 8. Then we're going to recopy this back down because we didn't do anything with it. And I like to be on the same line every time I'm doing anything, so it's just line by line by line. It just helps you make sure that you're not missing anything and you're including everything. So now we're going to box and circle. So we're going to box anything with a variable, circle anything with a number, and make sure you include the sign with the box or the circle. And now I'm able to combine these 2 boxes together, ignoring this negative 8 for a second. So I have 4x plus 3x, which is 7x. And then I have negative 8 minus 8, so I'm ignoring this positive 3x for a second. So I have negative 8 minus 8, which is negative 16. You owe me $8, then you borrowed 8 more, now you owe me 16. And that is as far as you can go because, again, 16 doesn't have an x. It is still married. Okay, going on to the next problem. We're going to add and subtract linear expressions. So they like to put parentheses around these linear expressions to start to show you that there are 2 of them adding together. So what we're going to do is we're going to rewrite them without the parentheses on it. So instead of writing the parentheses, we're just going to rewrite it without the parentheses to start. And that's going to help us when we are trying to box and circle. Now here we have a plus, a negative. Well, plus a negative is the same as subtracting. Whenever the signs are different, it's negative. Whenever the signs are the same, it would be positive. So, and then we're going to rewrite the positive 3. So now we can go ahead and box anything with a variable, circle anything with a number, box anything with a variable, circle anything with a number. So now I'm going to be able to combine this 3x with a negative 2x, ignoring that 5 for a second. So we have 3x minus 2x, and 3 minus 2 is 1, and it's 1x. And we can rewrite this as x later, but I'm just writing 1x so that you can see where I got it from. And now we're going to do the circles. So we have 5 plus 3. Well, I know 5 plus 3 is 8. So it's a positive 8. So instead of writing 1x plus 8, we're going to take out that 1 and just write x plus 8. It's kind of the same idea of writing 2.0 or 2. It's the same thing. So this is the simplest form of combining these like terms. You cannot combine x with 8 because 8 does not have an x. All right, now we're going to subtract the two linear expressions. So we have, rewriting it again, so we have 4x minus 3 minus 2x plus 7. So I'm going to box and circle. So I'm boxing anything with a variable, circling anything with a number, including the sign, boxing, circling. So I'm going to combine these two boxes together, ignoring this negative 3 for a second. So we have 4x minus 2x. Well, 4 minus 2 is 2, so 2x. And then I'm going to combine this negative 3 with a positive 7, ignoring this negative 2x. Negative 3 plus 7 will give us a positive 4. And because you cannot combine 2x with 4, because 4 doesn't have an x, it's as far as you can go. So that is your answer for number 2. All right, let's move on to the next slide. So now we're going to do a sequence, an arithmetic sequence. An arithmetic sequence is actually, each term is found by adding the same number to the previous term. So what that means is when you're moving from this number to this number, you're going to be adding the same as when you move from this number to this number. So the problem is trying to find out what that number is. So what you're going to do is to find the difference between each of the numbers. So you're going to work your way through. So finding the difference means you're just going to subtract. So 0.4 minus 0.1 will give us the difference between the two. So we can see what they added to 0.1 to get to 0.4. So 0.4 minus 0.1 is 0.3. And we're going to test it with this one too. So we have 0.7 minus 0.4 gives us 0.3 again. So the rule is plus 0.3. And then the second part is then write the next 3 terms in each sequence. So I'm going to use a semicolon to show the second part of the question, because in this question it doesn't say A or B. So you're going to use a semicolon to show that there's 2 parts. So all we're going to do is add 0.3 to the last number to find out what the next one is, which is going to be 1.3, because 1.0 plus 0.3 will give us 1.3. Then we're going to add 0.3 again to find the next one. So 1.3 plus 0.3 gives us 1.6. And then I'm going to add 0.3 on to 1.6, getting 1.9. And that is the last of what we need to find. So there's 3 terms, the next 3, and this is the rule, adding 0.3 each time. So that would be your answer to number 1. All right, for this one you're going to do the same thing. You're going to subtract 26 from 34, and that would be 8, and then 42 from 34 to see if that is also the same rule, and that would be 8 as well. So that is the rule, plus 8, and then the next 3, use our semicolon, is just going to be adding 8 to this. So 50 plus 8 is going to give us 58, and 58 plus 8 will give us 64, and 64 plus 8 gives us 72. So that is the next three terms. So the rule is plus 8, and the next three are 58, 64, and 72. All right, moving on to the next question. We have write an expression to represent the word problem below. So Joseph and his friends paid a total of $9 for tickets to the school basketball game. While at the game, they bought 6 slices of pizza at X dollars each. So on the right, I'm going to break this apart. So we have pizza is represented in X, and 5 bags of cotton candy at Y dollars each. So cotton candy is going to be Y, and 3 chocolate milkshakes at Z dollars each. So chocolate milkshakes is going to equal Z. So now down here it says write an expression to show the total cost of admission and the snacks. So and means plus. So the total cost of admission was up here, $9, and the snacks. Well, I know he bought 6 slices of pizza, so that's going to be 6 times however much it cost. So 6 times X. And then they bought 5 bags of cotton candy, so that would be 5 times the dollars of cotton candy, which is 5Y. And then 3 chocolate milkshakes, so 3 times the Z. So that is your expression because there's no equal sign in there. So that's answering for A, and now you're going to use this to answer B. Now they gave you values for B. So now you're going to actually plug in those values. So we're going to rewrite our expression down here, plugging in those values. All right, so 9 stays the same. And instead of writing X, because now over here we have X is going to be equal to pizza, and I know pizza costs $2. So now I'm going to change my key to say how much each thing costs, because that's going to help me plug them in here to solve it. And then cotton candy, instead of Y, cotton candy is now going to be 3. And for milkshakes, Z, milkshakes cost $3. So now I'm going to plug in these numbers for where these variables are in our expression. So instead of writing X, I'm going to write 2. Instead of writing Y, I'm going to write 3. And instead of writing Z, I'm going to write 3. Now I'm just going to solve it. So I have 6 times 2, which is 12. 5 times 3, 15. 3 times 3, 9. And there's plus signs in the middle here. 9 plus 12 is 21. 15 plus 9 is 24. And 21 plus 24 is 45. So they spent $45 on snacks and tickets into the basketball game. All right, moving on to the next slide. We have finding the greatest common factor of each pair of monomials. So a monomial, again, is a number by itself, a variable by itself, or a product of a number and one or more variables. So a product of a number and a variable would be like 2x. And a product of a number and more than one variable would be like 2xy. So because 2 is multiplying with the x, that's a product of a number and a variable. And then when we add y, now we have 2 variables. So now it's a number and a product of a number and 2 variables. So that's what that looks like. Or more variables for the part of that definition. So what we're going to do is actually factor and each of these to find the greatest common factor between them. So the first way you're going to do it is you're going to write out 12CD and think about what multiplies to be 12CD. Well, to get 12, I know 2 times 6 multiplies to be 12, but you're going to have to find out what prime numbers multiply to be 12. So prime, remember, is a number that can only be divisible by 1 and itself. So 2 is a prime number, 5 is a prime number, 7 is a prime number, and so on. So in order to multiply to be 12, 2 times 6 multiplies to be 12, but 6 needs to be broken down into 2 prime numbers, which is 2 and 3. So 2 times 2 is 4, times 3 is your 12, and then times C times D in order to get the C and the D. So now we're going to do the same thing for 36CD to find what's in common. So I know that 12 is 1/3 of 36. So if that's the case, all I need to do on this that they already did for 12, I'm going to add another 3. Because 2 times 2 is 4, times 3 is 12. Well, times another 3 would give us 36. And then I can add on our C and our D. So if you notice a pattern or a factor within the problem, use that to your advantage and not have to do the problem all over again for the second part. So what you're going to do is you're going to find the matching pairs between them. So we have a set of 2's in each of them, so we're going to circle that. And then we have 1 3 in here, but we have 2 3's down here. That means there's only 1 3 in each one that actually match up. So this extra 3 is not going to be part of the factor between these two. It's only a factor of 36. And then we have a C in both of them. And we have a D in both of them. So now we're just going to pull down one set of each of these, showing where they matched. So each of them have two 2's, each of them have 1 3, each of them have 1 C, and each of them have 1 D. So now we're just going to multiply all the way across. So you have 2 times 2 is 4, times 3 is 12, times your C, times your D. So that's 2 times 3 is 4, times 3 is your 12, times the C, times the D. So between 12CD and 36CD, 12CD is your greatest common factor. Because 12CD occurs in both of the problems, both of the monomials. All right, now looking at 18-8x and 20a. We're going to break apart 18-8x. So we have 2 times 9, but 9 is a composite number, so we need to make it a prime. So what numbers multiply to be 9 that are prime? 3 and 3. So 2 times 3 is your 6. 6 times 3 is 18. And then we're going to multiply by a and by x. So that's breaking it apart, 18-8x, 8ax, and then we have 20a. So what multiplies to be 20? 2 and 10. So we have 2. But 10 is a composite, so we need to make it a prime. The prime numbers that multiply to be 10 is 2 and 5. I like to put the numbers that match together, so instead of writing 5 first and then 2, I write them together so that when I go to circle them like here, they can circle them easily if they match up. And then we have an A. So we have one set of 2's that match up. These numbers don't match up together, but we have an A that happens in both of them. So now we're going to bring out a 2 occurs in both, and an A occurs in both, and then we're just going to multiply them. So 2 times A is 2A. So the greatest common factor between 18ax and 20a is 2a. All right, moving on to the next one. 3x squared. So we're going to break apart 3x squared. So 3 is already a prime number, so you're good with that. And then x squared is x times x. And now we're going to break apart 13x. Well, 13 is also a prime number, so it's just going to stay the same. And then x. So the only thing that matches up between 3x squared and 13x is 1x that occurs in both of them. So your greatest common factor between those two monomials is just x. All right, moving on to our last and final slide. We're going to factor linear expressions. Now, factoring linear expressions is just one more step on top of greatest common factor. So it's the same thing that we did before, except for now we're going to be adding or subtracting in the middle of them. So we're going to break apart 12x to start, and that would be 2 times 2 times 3. Remember, these have to all be prime numbers. And then our x, and then we're going to break apart our 8. And 8 is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we have a set of 2's that occurs in both of them. So I'm going to circle that. And I'm going to bring out the common thing that happened, which is the 2 times 2. And 2 times 2 equals 4. So this time, instead of saying 4 is a common factor, we're just going to have 4 on the outside of our parentheses. And what's going to happen on the inside of the parentheses is two things. You're going to have a number here and a number here. And you're going to find these numbers right here. So we have 3x that we didn't use, and we're going to combine that together and put it here. And then we have a 2 that we didn't use, and that's going to go right there. Now your decision in the middle is going to be based on what you have over here. So whether or not you put a plus or a minus sign is how this answer is in the beginning for the question. So because this is a positive 8, when you're doing distributive property, 4 times what kind of 2 would give us a positive 8? Well, a positive 2 would give us a positive 8. So if you're to check your answer, you can go back and do distributive property. 4 times 3x gives us the 12x. And 4 times 2 gives us the 8. So that is our answer. 4 times 3x plus 2. And you're going to do the same thing for number 2. So we're going to evaluate or break down 4x. What multiplies to be 4x? 2 times x. And then what multiplies to be 28. We're not going to pay attention to this negative right now. We're going to put it on after we get to the point where we're putting it into parentheses. So we're going to first break apart 28. So 2 times 2 is 4, and 4 times 7 gives us 28. And there's no variable, so that's it. And so we have a set of 2's in both of them. So when you pull it out, you get 2 times 2, which is your greatest common factor, 4. And that's going to be the outside of your parentheses again. And remember, we have something on the inside on the left and something on the inside on the right. So what's ever left over, x right here, is going to go here. I can change that color if that helps. And what's ever left over is going to go on the right. So this top number is going to go here, and the bottom one's going to go on the right-hand side. Remember, we're going to make our decision based on what was in the original problem. So this is a negative 28, which means when I do distributive property, 4 times what kind of 7 would give us a negative 28, and that would be a negative 7. So 4 times x would give you your 4x, and 4 times the negative 7 would give us our negative 28. So this is the answer for factoring this linear expression. Factoring it would be 4 times x minus 7. All right, now looking at number 3, I'm going to do the same thing. What multiplies to be 4x? Well, that's 2 times x. What multiplies to be 35? 5 times 7. And those are all prime numbers. Now, there are no matches between 4x and 35. So nothing occurs in either one of them. So because of that, your answer is going to be cannot be factored. And your answer is going to be exactly what the problem started out with, 4x plus 35. So some teachers might say you could just write down cannot be factored. Some teachers might say your answer would be 4x plus 35. For me, I want you to write both of them. So make sure you do both of them, cannot be factored and 4x plus 35. Butterfly. So this is the end of the video, and I hope you learned a little bit more about evaluating, simplifying, and rewriting expressions and factoring expressions. And I look forward to making more videos for you. Please make sure that you click subscribe and comment below if you have any questions or any more ideas for future videos. And I hope you have a good day. Talk to you later. Ciao, ciao.